All right, again, it is the expectation that everybody has their test review out, that everybody's phones are put away, and that you are actively participating in this. If we are going over one of the problems that you already did on your paper, you should be checking to make sure that you got the right answer on it. If not, that's a chance to ask clarifying questions. All right? Number 13. What do we call this object right here? An angle. Trick question. Not a trick question, but kind of a trick question. How many angles are in the picture? 3. We have 2 little ones, these 2 right here, and together they make the big angle. Let's look at the equation that they have written. What is this? Measurement of angle SIK. So it's an angle. Is that one of the big ones or little ones? Little. So we have a little angle. And then they are adding that to angle KIT. Is angle KIT big or little? Okay, thank you. Is angle KIT big or little? Little. So they're adding the 2 little angles together, and they have that equaling angle SIT. Is SIT big or little? Big. What is it that allows me to add 2, thank you so much, sir, 2 little angles together to get a big angle? Angle addition postulate. Yes. Angle plus angle equals angle. Little plus little equals big. That is the angle addition postulate. So far, so good? All right. Let's look at number 14, and then we'll go back and look at number 5, and then I'll take more requests. Well, hold on. While I'm on this page right here, do you want to do 11 and 12? Because they're fast. All right, let's do 11 and 12, and then we'll go look at 14. Number 11, it has segment AB is congruent to segment CD in the if, and we want to look for what changed over here in the then. CD was on the right-hand side. It didn't change at all, but it did flip to the other side. It did go over to the left. AB was on the left. It flipped over to the right. Other than that, nothing changed. No new letters, no new numbers, no pluses or minuses, no anything like that. Just took this and flipped it around. That's the symmetric property. Nothing changes, it just lets me flip. Symmetric property. Number 12 is one of my favorite ones. Number 12, we have a big long equation over here with the if, and we have a big long equation over here in my then. What's different between the big long equation in the if statement and the big long equation in the then statement? Angle 3 is here. It was replaced with angle 4, and that is substitution, yes. We know that we can do that because here it said angles 3 and 4 are the same size. I'm only allowed to trade out things that are the same size. That is our substitution property. Perfect. All right. Let's look at number 14 now. Number 14, if AT equals PC, then AT plus 87 equals PC plus 87. Between the if and the then, what's different? The 87s. And we've got one on each side, right? Whenever we do the same thing to both sides, that's a property of equality. If you do it to both sides, it's a property of equality. This is the addition property of equality, yes. Because nothing got traded out. In order for it to be substitution, You would either have to see this go away and be replaced with something else, or you would have to see this go away and it replaced with something else. That's substitution. Addition, property of equality. You guys okay if we just do 15 and 16 while we're here? All right. 15. There's no if, there's no then. There's just a single equation, HI equals HI. Yes, reflexive property. This is our reflexive property. Reflexive, R-E-F-L-E-X-I-V-E. R-E-F, that's a cursive F. Got it. It sounds like reflective, but it's reflex. Reflexive. All right. Let's look at number 16, and then we'll go do number 5. Number 16, my if statement has a fraction in it. A fraction means what operation is taking place? Division. When I come over here to my then, is there still division? No, now we have a 4 that is being multiplied. Well, there wasn't a 4 over here with PQ in my if. And the 1/4 in front of MN is gone, right? Well, what is 1/4 times 4? 1. So if I multiply this by 4, I get just one of these. So we did the same thing to both sides. I didn't see it like I did here, but it's still the multiplication property of equality. It happened to both sides. It had been division, but then it became multiplication. That's what we did to both sides. This is the multiplication property of equality. All right, number 5 was the next one we were asked for, and then I'll take more requests. Number 5. It's right here. If 2 lines are perpendicular, then they intersect to form right angles. Identify the following statements as the contrapositive, converse, or inverse. I want to go back and remember how we make the contrapositive, the converse, and the inverse. Let's start with the first one that we learned about. The first one that we learned about was the converse. How do I take a statement and make it the converse? What was the word that I used? Switch. Here's the way I would approach a problem like this. Instead of reading the 3 sentences and deciding which one it is, I'm going to find one of these. I know what it means to do. I'm going to look at my sentence and I'm going to make the converse in my head, and then I'll go figure out which one matches that, and I'll mark it as the converse. So if I switch, if 2 lines are perpendicular, then they intersect to form right angles. What would that sound like? If 2 lines intersect to form right angles, or to form a right angle, then the lines are perpendicular. Which one sounds like that? C. If 2 lines intersect to form right angles, then they are perpendicular. That's my converse. So again, I'm not going to read the sentences and pick out which one it is. I'm going to decide which one I'm going to go and find first. The second one that we learned about was the inverse. How do we make the inverse? Yep, not. Remember, for this one, the order doesn't change. I leave if two lines are perpendicular at the beginning, but I have to insert what word? Not. So if two lines are not perpendicular. Which one starts that way? B. So that's my inverse. And so process of elimination tells me that A is which one? Contrapositive. How do we make the contrapositive? Switch and not. So when we switch and not, it would be if two lines do not intersect to form right angles, then they are not perpendicular. If two lines do not intersect to form right angles, then they are not perpendicular. That's exactly what it says right here. So that is my contrapositive. What else would you guys like to see from the review? Number 4? Is that what you said, Andrea? Okay, I wasn't sure if I had heard the same thing from somebody else. Number 4, so let's go back one. So front page. If B is the midpoint of segment AC, then said the length of segment AB equals the length of segment BC. We need to identify the hypothesis and the conclusion. Then we're going to write the inverse, and we're going to determine whether or not it's possible to write a biconditional statement. How do I find the hypothesis? It's always after what word? If. It's going to go from here up until we get to the word then. This is a sentence. What do you do to the first word of every sentence? Capitalize it. Now, in this case, the first word is just the point B, so I don't have to worry about that. But please remember tomorrow when you're doing your test, if the word after if is a word and not a point, you have to remember to capitalize it. You are writing sentences for me. So I would write B is the midpoint of AC. I need you to put that away, please. B is the midpoint of segment AC. Period at the end, because this is a sentence. How do we find the conclusion? It's after the word then. This is what is after the word then. Most of the time, this will be another sentence. Remember, if is not actually part of the hypothesis. It's my signal word. Then is not part of the conclusion. It's my signal word. So my conclusion would be the length of segment AB equals the length of segment BC. So far, so good? Most of the time, I would be writing a full sentence here. And we can go look at number 3 in a minute if you want to, because 3 is like this one, but we have full sentences there. You want to go look at that one? Okay. State the converse. What do we do for the converse again? Switch. So how will this start? Yes. If segment AB, if the length of segment AB is equal to the length of segment BC, then B is the midpoint of segment AC. Beautiful. Is it possible to write a biconditional for the conditional? If so, write the biconditional. If not, explain why / give a counter example. If we can't write the biconditional, I want a counter example. And a counter example, 90% of the time, should be a drawing. But I need you to actually put it away. Thank you. How do I know whether or not it's possible to write a biconditional? both have to be true. So we need the conditional statement to be true. And we need the converse to be true. So let's look first at our original conditional statement. If B is the midpoint of AC, let's sketch a quick picture. We have a segment called AC, and B is the midpoint. Are AB and BC the same length? Yes. So is that original conditional statement true or false? It's true. The converse. Now I don't know that I have a segment AC. What I know is that AB and BC are the same size. And I'm saying here in the converse, if I have two segments that have the same size that touch at this point, then B has to be on a segment called AC and it has to be the midpoint. This is false. This one is false. This one up here is true, but this statement here is false. So we are going to give a counterexample. Again, 90% of the time when you give a counterexample, I want you to draw it for me. Yes, Kason? Yes. The reason I want you to draw this for me is because too many times when we use words, we don't actually give an example. We explain a concept. When you give an example of something, you should be able to point to it and say, there it is, name, date, and time, and then this goes right back here. So, to illustrate this point, when my daughter was little and in preschool, she was learning about her shapes. I taught her about an octagon. How many sides does an octagon have? 8 sides on an octagon. And I told my daughter that. I said, an octagon is a shape with 8 sides. And she kind of nodded and smiled. She's like, I'm 3, I don't understand. But then we were out on a walk later, and we saw a stop sign. And I could point to the stop sign, and I could say, this right here, this is an octagon, and we could count the sides on it. But she could see it then. Instead of just hearing about it in words, she could see a picture of what we were talking about. A counter example, any kind of example, should be able to be pointed to and be like this right here. This is what it looks like. So if at all possible, I want to draw a picture for my counter example. Now in my picture, for a counter example, I have to make this true, but this false. All right, so I want the first part to be true, but I want this to be false. Here's a possible counterexample. This is not the only one, but this is one thing that I can point to say this is why it's not true. What if I have a point A right here and a point B up here and a point C down here? AB and BC I'm marking as the same size so that they have equal measurements because I want this to be true. And then I'm going to connect the bottom. So now I have a segment AC, that's this. But is B the midpoint? No, B is not even on that segment. I have segment AC, but B is not on that segment, so it can't be a midpoint. But AB and BC are still the same size. This is what a counterexample should be. You should be able to look at it and say, here's an example of why this is false. All right? Let's go look at number 3, and then I'll take another request. But number 3 is similar to this one, and so we'll get a little bit more practice with this. All right, hypothesis and conclusion first. My hypothesis would be what? Super close. 2 angles are supplementary. Remember, if is my signal word, and so it's all the stuff that comes after the if over to my comma. That's my hypothesis. This should be a sentence. A sentence has to start with what? Capital letter. So 2 angles are supplementary. The conclusion. We have to watch for two things on the conclusion. One, it has to start with what kind of letter? You're writing a sentence. Has to start with a capital letter. Even though I'm pulling it from the middle of my original statement, I have to start this with a capital letter because this is a sentence. The other thing that I have to watch out for with the conclusion is we don't want any pronouns here. Are there any pronouns in the conclusion? Yep. What is the pronoun? What'd you say? Then is not a pronoun. There. What do they mean by there? How many angles? 2 angles. I'm not going to write there. I'm going to write 2 angles. Because this is a standalone sentence. And if I just walk up to somebody and say, the measure of their sum is 180, they're like, what are you talking about? I need the subject of the sentence in the sentence. Starts with a capital letter. So, the measure of 2 angles sum is 180 degrees. Remember, we do not put the word then in the conclusion. Then is just our signal word. If is a signal word, but it's not part of the hypothesis. Then is a signal word, but it's not part of the conclusion. All right, then we're going to write the converse, where we're going to switch. So instead of saying if 2 angles are supplementary, what are we going to say at the beginning? If the measure of 2 angles sum is 180, if the measure thank you, of 2 angles sum is 180. What do I need after the 180? I need a symbol next. A comma. Before we start our conclusion, before we write the word then, we put a comma. And then I have the word then. Then what? Yep, then they are supplementary. Then they are supplementary. I can use pronouns in the middle or at the end of my sentence. So it's okay that I didn't say 2 angles again, because right here I said 2 angles. So I can use a pronoun here. You can also just repeat it and say, then 2 angles are supplementary. That would not be wrong. So you can repeat the subject of the sentence, but we don't put any pronouns at the beginning of the sentence, because people won't know what we're talking about. So we put the subject at the beginning. All right. If possible, or is it possible to write a biconditional for the conditional? If so, write the biconditional. If not, explain why. Give a counterexample. So is it possible? We need our conditional to be true, and we need the converse to be true. Is the original conditional true? If 2 angles are supplementary, then the measure of their sum is 180. Yes, that is a true statement. Is the converse true? If the measure of 2 angles sum is 180, then they are supplementary. Yes, that is also true. So can I write a biconditional? Yes. What are the special biconditional words? If and only if. Tomorrow on the test, I will not be able to tell you what a biconditional statement is. I will not be able to tell you the special words that we use for a biconditional. I can remind you, if you say, what's a biconditional? I can say, what are the 4 special biconditional words? I could remind you that way, but that's as much as I'm going to be able to say. Does this go at the beginning? No. Does if go at the beginning? No. I have 2 ifs right here, so I don't need another one at the beginning. So we're going to start with just the hypothesis. It doesn't matter whether I go from my original statement or from the converse, because they're made up of the same pieces. We write only one statement for a biconditional. So you pick either this one or this one. We're not going to write the if at the beginning, so we're going to start with just a capital letter for the word that comes after if. So I'm going to use this one up here. We're going to say 2 angles are supplementary. 2 angles are supplementary. What comes after that? If and only if. Yes. If and only if. You do not have to put yours in capitals, but I'm doing that so that when you're studying for the test, that jumps out at you. It goes in the middle, in between the hypothesis and the conclusion. No if at the beginning of the sentence, no then in the middle of the sentence. This is what goes in the middle. If and only if the measure of their sum is 180 degrees. All right. So now we've got to practice with 2 of these with the biconditional, one where we couldn't write it and one where we could write it. What else would you guys like to see from the review? We got 15 minutes left. That's at least 2 or 3 problems. Number 2 and number 6. All right, let's do 2 and 6. Let's do 2 first. Number 2, write a conjecture to find the 5th term in the sequence. A conjecture is a way of putting into words the pattern that we found, so someone could use that pattern to keep going. So how do you go from 60 to 53 and from 53 to 46 and from 46 to 39? Going down by 7 each time. So my conjecture would be each term in the sequence is 7 less than the previous term. They didn't ask us to do this, but could you use that pattern now to find the next one? What would the next one be? 32, absolutely correct. And then we could keep going with the pattern. If I've got a calculator handy, it gets really easy. I just do -7, enter, -7, enter, -7, enter, and I can keep going, keep going, keep going. All right, let's look at number 6. Problem number 6. What did we do for converse again? Switch. Remember, no pronouns at the beginning of sentences. So when I switch, I have to watch to make sure that I'm replacing pronouns with whatever the subject of the sentence is. What's it going to sound like if I take this if-then and I switch it? What do you mean by they? If 2 angles are supplementary. You're not wrong, but we just want to make sure at the beginning of the sentence we're getting our subject in there. If 2 angles are supplementary, then what? Then they are a linear pair. I can use pronouns in the middle of my sentence, but I can't use them at the beginning. So if 2 angles are supplementary, then they are a linear pair. And then we're supposed to decide whether that's true or false. So before we decide whether or not this statement is true or false, let's go back to the original one and decide whether that one's true or false first. If two angles are a linear pair angles look like what? They have a shared side, and together they make a straight line. So two angles like this. Are those angles supplementary? Yes. They make a straight line, and a straight line measures 180. Supplementary means they add to 180. So this is true. This statement says if two angles are supplementary, if two angles add to 180, then they have to be a linear pair. They have to be side by side like this. That is false. So that means we need a counterexample. 90% of the time, you should be trying to draw a picture for this. Give me an exact example. So I want them to really add up to 180. It has to make the first part true, but I don't want them to be a linear pair, which means I don't want them to touch. So I could draw two angles like this. Is that a linear pair? Nope, they don't touch. So that's not a linear pair. But I need to make them add up to 180 so that they're supplementary. So I need two numbers that add to 180. I could do 90 and 90. I need to redraw my pictures if I use 90 and 90. I could do 180. So I'm going to draw two counterexamples so that I can use yours, Kaysen, and I can use yours. So I could say this is 100 degrees, and this is 80 degrees. That adds to 180, but it's not a linear pair. We could also do what Kaysen said and draw two right angles. Right angles are 90 degrees, so it adds to 180, but they're not touching, so they're not a linear pair. So far, so good? All right. Let's go look at part B. Part B is the inverse. What do we do to find the inverse? Not. Order stays the same, but I come up to this front part, and I put the word not in there. And then I go to the back part, and I put the word not in there. So what's this going to sound like? Yes. If two angles are not a linear pair, then they are not supplementary. Then we have to decide whether that's true or false. Here's the thing about the converse, the inverse, and the contrapositive. Whatever the truth value is on the converse, the inverse will have the same truth value. So if the converse is false, what about the inverse? Has to be false. Converse and inverse have to have the same truth value. They will always have the same truth value. Converse and inverse will always have the same truth value. So that means another counterexample. It's false for the same reason my converse was false. I can use the same counterexample here because it's false for the same reason. I want to draw angles that are not a linear pair, but that really are supplementary. So I could do that again with my 100-degree angle and my 80-degree angle, or I could do that with the two 90-degree angles. Not a linear pair, but they do add to 180. Same thing up here. Not a linear pair makes the first part true. Not a linear pair. Second part false. So far, so good? All right, we got one more to go. We just have contrapositive. How do we write the contrapositive? Switch and not. Or you could say not, switch. It doesn't matter what order you do it in. We need not with the beginning, not with the end, and we want to flip it around. So what would that sound like? If two angles are not supplementary, then what? Then they are not a linear pair. Yes. If two angles are not supplementary, then they are not a linear pair. Do you remember how I said the converse and the inverse will always have the same truth value? The original statement and the contrapositive will have the same truth value. What did we say about this original statement? Was that true or false? We said that that was true. And we even had a picture to go along with it. There's my linear pair. So if that's true, what about this one? Would also have to be true. Let's talk about why. So no counterexample, but we do have to give an explanation. If it's true, we explain. If it's false, we draw a picture of why. If two angles are not supplementary, that means they don't add to what? They don't add to 180. A linear pair makes a straight line. And a straight line is 180 degrees. So for my explanation, I can say a line is 180 degrees if two angles don't add to 180, then they can't make a line. A line is 180. If the two angles don't add to 180, then they can't be a linear pair. They don't make a straight line together. All right. We have 2 minutes left. That is just enough time for me to show you exactly where in Canvas you can go to find the answer key. Does anybody remember where to go for this? We go to Canvas. Once you're in Canvas, where do you go? Go to Modules. So we click on Modules. Once you're in Modules, what module are we in right now? We're in Module 3A. You're going to scroll down through Module 3A until you see today, Tuesday the 16th. You click on that. That'll open up this page. I'll have the videos posted here later today. And then down at the very, 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 very bottom of the page has the answer key. And if you click on that, that has all of my work on there. So you can check your answers. You can get clues or hints if you're stuck. Please send me messages in Canvas if there's anything that you're absolutely stuck on. If you can't figure it out with the answer key and you're stuck and you need some help, send me messages. All right? But you will be turning in the answer key tomorrow. Not the answer key. You'll be turning in the test review tomorrow when you come in to take your test.